All right, so this is the GeoGebra activity for pages 11 and 12. I just want to show you some of the features of your GeoGebra activity. So first of all, you are able to change this triangle any way that you want by just dragging the vertices around. You can, you can make this beautiful obtuse triangle. You can make a right triangle. And if you're not sure it's a right triangle, you can actually measure the angles. I clicked this angle tool right here. So we're going to measure the angles. So if I want to measure angle B, it's going to tell me that angle B is 83 degrees right now. If I want to make sure that if I want to turn this into a 90-degree triangle, I can just drag angle, the vertice A around. I have to unclick the measure tool again. And then, so I don't want to do that. So I can drag this vertice and it'll just let me move it around. So let's say that we want to, suppose that we want to focus on what those special centers of our triangle are. Remember, they're the centroid, which is created by the medians. So I see that when I click the medians tool and the centroid tool, these are my medians. Remember that they go from the vertex to the midpoint. Those are my midpoints of all of my sides. I also have the orthocenter, which is created from the altitudes of my triangle, And it's telling you that these are altitudes because they're perpendicular. Those are your little 90-degree segments. I also have the incenter, which is created by angle bisectors. And lastly, I'm going to change this triangle just a little bit so you can see the circumcenter. The circumcenter is just created by perpendicular bisectors. Okay, so there's my circumcenter. So our first question asks us, which triangle centers always stay on the interior of the triangle? Well, right now my circumcenter is not on the inside of my triangle. So the first thing I want to do is kind of manipulate my triangle a little bit to put that circumcenter on the inside. And then I want to see if my incenter is on the inside and my orthocenter and my centroid. So right now they're all on the inside of the triangle, but when I move the vertices around a little bit, I see that I can make the orthocenter and the circumcenter leave the interior of the triangle. Why is that? Well, what kind of a triangle is this? Is it a right triangle? Is it acute or is it obtuse? And again, I can go up to this angle measuring tool and I can measure the angle of my triangle and it'll tell me that this is greater than 90. So when the triangle is greater than 90, it's obtuse. When one of the angles of a triangle are greater than 90, you have an obtuse triangle, okay? So if I want to move this around, I have to go back to the arrow tool. This is going to let me adjust it. And I say, well, what kind of a triangle must it be for them to all stay on the center or the interior of the triangle? And it's when all of my angles are less than 90. So that would be an acute triangle. What happens when I just have a right triangle? When I have a right triangle, my orthocenter actually lies on the vertice of the right angle. My orthocenter actually lies on the vertice of the right angle. And it looks like the circumcenter lies on the hypotenuse. So as you go through this activity, you're going to be asked to create equilateral triangles or isosceles triangles, and you're going to see what happens to these special centers. So one of the questions asks you which segments always pass through the midpoints. So remember, our line segments are medians, altitudes, angle bisectors, and perpendicular bisectors. Whoa, that's a lot of information. And I want to see which ones just go through the midpoints. So I just try to look at them one special segment at a time. So I'm looking at the midpoints, and maybe I just want to see, do the perpendicular bisectors always pass through the midpoints? Well, yeah, they do. Even as I adjust the type of triangle that I have, I see that the perpendicular bisectors always go through the midpoint. Why? Because it has a bisector. It's cutting the segment length into two congruent pieces. So that means it has to go through the midpoint. What about the angle bisector? Well, the angle bisector doesn't have anything to do with the segment. It bisects the angle in half. What about the altitudes? Well, the altitudes also don't go through the midpoints, and you can see it as you adjust your triangles that those pink lines don't have anything to do with touching the midpoints. But what about the medians? The medians always pass through the midpoint. Why? Because the median is created by the vertex going to the midpoint on the opposite side. Okay? So you're going to play around with these and answer the questions that you have on page 11 and 12. And I will be back tomorrow. So I want you to work through pages 11 and 12. And then that's your activity for today. And then I want you to try pages 13 and 14 as your homework. It's actually pages 13, 14, 15, and 16. I'm gonna create a Delta Math assignment. You're gonna have a Delta Math assignment that kind of coincides with specific segments of a triangle. So take your time working through this GeoGebra activity. Don't stress. Tomorrow when I get there, we'll do some card sorts with shapes, and then I really want to focus on proofs because I love geometric proof, and I think that there's a lot of algebraic and algorithmic thinking that goes into geometric proof, and it's not been fair to you guys to try to figure that out on your own. So tomorrow we're going to flip backwards and go to lesson 5.2 and kind of do a recap, and then if there's time, we'll do pages 13 through 16 together. I still want you to try them. I still want you to try 13, 14, 15, and 16, but we'll go through and cover all of those together. Okay? I hope you guys are behaving yourselves, and I miss you.